So for my talk, we are going to discuss about reports generation using Go. Oh, so a little about me. Hello, I am Karen Matala. I am the CTO of OneExport.net, and I am a lead at Women Who Code Manila. Uh, we emerged as champion from the last startup weekend for women 2018, and I have been a Go developer for 2 years now. And many of us maybe discovered their green thumb while stuck at home. So I am a plantita. So let's have a code plan in order to execute this generation of report. So number one essential thing is to find a database. A database can be like maybe MySQL or some Excel sheet or a CRM. And the number two is actually opening our IDE. And third would be forking this GitHub repository. So let's head on to that. And number four is don't be afraid to fail and learn. So I would echo Angelica's point wherein you just need to dive in and don't be afraid to fail. So to the computer. So let me just head on to the GitHub repository. Oh, so wait. For the user and database plan, so again, it can be a MySQL or an Excel sheet. So it is important to have a goal in mind, who your end user is for the report. So it can be the sales team or the marketing team. And then make sense of the important fields and columns. So on opening your code environment, you have to set up your Golang. So if you haven't downloaded it, it's pretty straightforward for Windows and uh, Linux or Unix systems. You just have to be cautious on the Go path variable. So let's head on to the GitHub repository right now. There. So this is the GitHub repository. It's very easy to follow the README, right? But and then run it. It's best practice to have a README. But then what I would like to have this session is actually have the fundamentals and really learn to traverse this, right? And then it has 7 commits, which I think 5 is the most core. So we had a code plan of the database extraction of data. So let's expect that there is a need for database connection. So I made this folder. So observe the file structure of your repository or your code base. So you would have there a database connection, and then the export would be the export action or some build or transformation of export file, and then the task. So the database fields that we would have would be maybe a to-do app. So this is going to be a task table. And then some utility. Utility can be like the OS or operating configuration. So the other files, so .env.example is you can replicate this as your .env, and then git ignore for your ignoring some default files, and then go.mod. So I would echo the first presenter, Mitali, for go module versioning. So we will touch on that in a bit, and then some go.sum, and then the main entry point is the main.go. So of course the readme.markdown, and then the two app MySQL file. So let's head on to the commits. So the very first commit is at the bottom. And if we click on here, so the commit description is we set up go.mod for local package importing. Oh. So you can see here the .env.example. So this is like your template. We can practice here. I recommend going through the 12factor.net practice. So 12factor.net, it's a website or a document you could easily access right now. So this only tells you the best practices of the other developers or engineers out there that has built software as a service. And one of the pillars there is the config. So this section would say that it requires a strict separation of config from the code base. So that's why we are doing this .env file, that example. So when you fork this configuration or this GitHub repository, you will need to have like a .env file, and then you can see here. Yeah, yeah. Sorry, I thought my screen. You can see here I have a key value pairs. I have here a key of app env equal to local. So let's assume that this is going to be a production, a staging environment, or a local environment. And then I have this host part, and of course our database connection. So you have here a username database, what is the password of that database, and then what is the address, and then some port. And then of course for our app, we have like a to-do app. And then these AWS keys, you can ignore it for now, but we just had a service that, generates a file, and then after it generates a file, it would upload to a AWS S3 bucket. But for now, let's skip to that. And then of course the .git ignore file. So it comes to surprise that some developers forget about this file. So tendency is they upload like the whole node modules folder, which is really big, but that's okay. At least you get to iterate or learn about it. Yeah. So now we you can see here like an asterisk. That's like a wildcard, and then the file name. So .exe. So it would ignore all files that has a file type of .exe. And then the SSL certs. So let's not include that because we don't want anyone, just in case, to hack our servers. This is a very sensitive folder or file. And of course, our .env, we wouldn't want to commit that. It would break the 12-factor out. And then some IDE cache settings. And of course, our .excel file. So this go.mod, it's my first time actually to understand it in depth a while ago because of Mitali, right? Because I think that's just how I work or my friends work, the developers work. You just have to, you see this video tutorial, you follow it, and if it makes it work, then great, right? If the video tutorial said it's the best practice, okay, cool. Now I will just do it. But because of what Mitali said, now I know that, oh, I'm actually using Go module versioning, and I'm actually using the semantic versions. And there's a benefit on using semantic versions and the pseudo versioning, right? So that's really good to hear code gurus or go gurus, because at the end of the day, I don't know everything, but just try to be curious always. So go.mod, this file serves as your Go module dependency guide. So if you have written code from PHP, it's like your composer.json, and then on JavaScript, it's like your package.json. So when you invoke go get, it would install dependencies coming from this file. And so the main.go, so going on the directory, so imagine that this is your IDE. So the root folder, and then the root file is main.go. So it would execute, or that would be the entry point. So for every language, there's an entry point file. So this would be it. And then you have here the package main. So package is, I would say, it's like the directory or the folder, and then it is on the main. So now we have some dependencies to import. So FMT or format. So it's a standard library out of the box. And then I have here my repository, if you could see, Karen Irene Cano, and then my repository name. So this would be your custom local package. It needs to be on the Go mod file. So let's see now. So it is here, module, and then my GitHub repository. This would enable you to actually reuse files or separate files into folders, because it could get a little bit messy if it's all in the same folder. But yeah, as you progress, it gets big. So now we have here a function. So it's func main and then some starting and closing brackets. And then I just have to POC, or proof of concept, trying to learn Go. Uh, some format, print line, hello. And now you can see a utility and then a dot and then a setup function. So if you could traverse that, you will find the instances of utility coming from this line of code. So expect that you will find a utility folder or a utility file. And then inside of that file, you would expect something like a setup function. I don't think there's IntelliSense in GitHub, or it's only on master branch. But I remember when I click and hover, there's a feature in GitHub one time. Yeah. Okay. And then some README. So again, it's best practice to actually have a README so that your code developers know how to set it up. And then another file would be the environment.go. So you see here, it's under the folder of utility, and then the file name is environment.go. So meaning to say, as long as they are on the same folder, as long as they are on the same package, across different files, you can access that. But do note, there's a thing, a format in Go, like if the function name is a small letter, it is only accessible within that Go file. But then if it's on a capital letter, it is accessible like global. So this function, we need to set up our keys and value pairs. Observe that the function name, yeah, starts with a capitalized letter. So I just POC'd the idea of, what does even a local or a global scope function mean? So while I was doing this, I would run the code and it would break things. And it's all right, because when you break things, you tend to fail fast and recover fast and just try to learn. So that's the first commit. I was just simply again going back to the main.go. I was printing text and then just trying to try out things. So on the next commit, so now you create your file referencing env file, and then setting up the operating system environment variables. So the goal in mind is I really need to access the database because I want dynamic data, right? So I need to connect to the database. So now, all right, on the main.go, you would need to say set it to the operating system environment. So maybe the idea is, I would imagine I need a way to access the key of the database username, but it's coming from a file, right? A.env. So that kind of flow is already your coding plan, right? So, okay, I need to access that file. So how do I do that? So going back to your utility, your environment.go, the beauty of Go is that you can actually import libraries as you type. There's an IntelliSense package in VS Code that you can download. And then if that package is or library is not used, Go would actually have an error that, hey, you didn't use this package, I'm gonna delete it. So going back on the setup, So now we have to really manipulate and access the env file. So as you can see here, um, I have this comma error syntax wherein I have a function called get CWD. CWD is like a current working directory of a string, or this .env references and assumes that you have copy and pasted the template, right, as .env file. So if you forgot that step, you might have an error, and then that's okay. You can always mend it as you go. So basically, this code would say that, okay, it would log the error. Hey, Karen, you forgot to create that .env. And then if it has no error, we go read the file. All right, I have read the file. It exists. Now what? So you have to manipulate the key value pairs and then understand how it is patterned. So going back to our .env example, going back, so um, understand how the pattern goes. So you have here maybe an equal sign as your delimiter for the key value pairs, and then a slash n or the next line. So that would mean another pair. So this is the code for that. Like I have a delimiter of a backslash n, and then I would split it up with equal sign. It's like explode or implode in JavaScript or PHP. And then as I loop over it, I would set it to the environment on the operating system level so that later on I could pick it up or get it. Sometimes I have an error. So before I actually made this function, I had a lot of errors. Like sometimes there are dirty data that I wasn't able to catch, like there's a space. So, and then there's a space or another underscore, but you will have those you will have those spikes of mistakes, and the secret is to just expect that you will have those spikes and you will have those plateaus, and just dive to it and go back to the goal there. Okay, so this is the setup, and then now you have set it up on the environment. Yeah. Oh, right. So the get CWD function, by the way, is just really checking if that file path string exists, right? If not, it would throw the error. So OS has some pre-built functions which you could refer. Okay. So going back on the main.go, so you just have to POC again. All right. Can I now really get a key and then get the value of it, because you will be using it everywhere. So now that is set up, now you can access your that env file. Let's try accessing our database. Okay. So on the database folder, I created this connection.go. So I have here a package database, and then I imported some of the libraries like some TLS because we have some SSL certs. So we needed those libraries, but essentially the important part here, if you don't have SSL, is the SQL and the IOUtil, and then of course the OS. Um, Still, we need to import our local packages, right? So you will need like this Go MySQL um, utility folder, because we will be reusing some functions from there. And also you can see here we are using a driver. So the Go SQL driver for MySQL. Then we have this variable, which we will also use as we progress. And then for the DB instance, you will see I explicitly have a capital letter here. And also, I think I read a somewhat a standard that if there's an acronym, it should be like DB. So if it's an ID, it's not going to be like capital I and then small d. It should be like all caps ID. So yeah, just to share. So function DB instance and then a pointer of SQL.db. So the very gist of this code is primarily to have some connection to your database. So I used here a env called app env. So we have this production SSL. So now on your .env, if you're going to deploy it somewhere, uh, you have to make sure that your app env is equal to production SSL if that's what you want to uh, compare, right? Because again, we are using SSL certs. And then now you can see I used here utility that gets CWD. Now, this became a big letter um, because I had to reuse it. So let's expect that there's a commit here that I change the utility get function, get CWD as capital letter. There, this was the commit. So before, it was a small letter. Now I made it to a big letter because I had to use it globally there. So I needed some client cert functions and then reference it. So we had some PEM files, some key files, CA certs. I honestly cannot explain to you what these preloaded functions say. I just happened to make it work, but you can navigate to the library link right here and let me know. But in a nutshell, I think it just deciphers the CA certs and make sure that there's no man in the middle attacks. Yeah. Okay. And then essentially, if you are not going to use a SSL cert, just navigate on getting your simple DB username and then password or the port. So maybe it's somewhat a AWS MySQL instance. You get that endpoint, and then you get that username and password, and then the thing is your settings in AWS RDS should be public. But yeah, so now when everything is set up, um, you will have your DB connection. So of course, all right, this seems to do the job, but how do I even know if it's working? That's why we are going to have to POC it. I would also like to touch that this is what Mitali mentioned. It's like the semantic versioning. Yeah, cool. Yeah, so you have a major and minor releases. Just go that some. I'm not sure what this is yet, but it seems like it's like the package lock JSON and the composer JSON lock, wherein it maybe if you could go get it would specifically just get this. So it's like the pseudo version, maybe. Let me know on the comments. Okay, let me just try to search for the main.go. Well, I guess the execution of main.go is not here. Let's go. Let's go on the other commits then. Add in our database. Is this, are you the one? No, we're done in that. Oh, this commit is just making this string into a rune because essentially this is a integer or yeah. there. So on our main.go, we need to reference the task um, folder. Now, on the task folder, I would have a get all by user. So let's head on to the um, task folder. So on the task folder, I have like a file called task.data.go, and another would be the task.go. So the difference is that on the task.go, it holds the task struct. So again, I have this package task. It would mean that it's on the same folder. So a struct is a collection of data fields with declared data types. So I just have to declare the columns or the fields from the database that I would um, reference here. So I have a type task and then a struct. So an opening and a closing, and then I would use a ID. It is an integer JSON ID, serves as the primary key of the task table. I would use a user ID, and then reference foreign key from a user table, owner of a specific task. Again, context is this is like a to-do app. And then I have a title, a short one title, and then is it complete, boolean, and then this would be the name of the table or the name of the column. And then a created at on the table, it is named like this one, created underscore at, and then updated at, and then it has an underscore here. Now that you have that struct, you would have this task.data.go. So you would have here the functions where there can be like the queries you could do coming from the database. So you can see here, I had an import where I reference the database folder. So I could get the functions in there. And then get all by user ID, take in a user ID, and get all its task. So when you observe this, it is on capital letter, and then I pass in a user ID variable and its data type. Hold on. Yeah. And then this parenthesis here is actually the output data type. At first, of course, I'm coming from a PHP background, engineer. So at first, it was like, what is this? Is this like a use function? Is it like a callback function? So there's like a return type hinting in Go, which is very strict, right? And unlike PHP, it's not. But in PHP 8, there's already that. But yeah, that's for another conversation. And then I just have this inherit the data type declaration. So I have a DB, and then I just get the DB instance referencing from that file import. And then I have this query. So this query will have the select star wildcard from the task table where user ID, the column name, is this query or question mark. So that query is now passed here. And then the db.query. So there's a documentation you can follow that is used on the database package. And anything after this comma, so let's say you have another parameter to pass in, right? Another question mark, you just add it here because it uses an interface. So it's like an argument interface. So you just have to comma separate it. And then this defer db.close, essentially just before the function closes or is done, it would close the database. So we have to close when you open it. We have to close it for that specific time. And then error, to catch the error if there's something wrong here, maybe a typo. I had that. And then all right. So now, of course, now that you have this query, and then assuming that it's all working, no errors, you would want to display it somewhere. And then the syntax on the documentation is that, okay, let's assign it on the results variable here. This is a comma okay syntax. So if it succeeds, it goes to this results, and then if not, it goes to not okay. So now, so results that next, it's a function, pre-built function, and you're in the for loop. So for each row, you will have to assign or build this instance. Like you have this var task. If you could remember the task.go we built, the structure. Now, on every results that scan, you reference the task that ID, and then the user ID, the title, and then for every field that you need. So the positioning of the columns should be the same that of the select query above. It should also follow the struct succession, because when I didn't follow it, like maybe I just put this at the top, it didn't work. So I just followed it. So yeah. And then now, where do I actually allocate it? Because I would need to maybe parse it or transform it to a much more insightful form. So I created this list or a slice, I would say. I'm I'm a bit confused on slice, arrays, and list, but there's a good documentation in Go, um, which you could have, which you can execute code immediately. So I think this is the list. If I'm not, no, a slice of task struct. Now you will have to append it there, this task instance on the task. All right, and then just return the task. If none, it would return nil. Okay, now let's look for the execution part of that, the implementation. So you can see here, this is the main.go. All right, we have set up the utility, and now I would like to use the function that I just created. So remember that you required a user ID, which is an integer. Now for this session, we will just hard code it. But as what would Angelica explained a while ago, they had a web app, which you can actually do. Like there's a package that you can just plug in play within Go, and then have it pass by request. But for now, let's just hard code it. So you see here a variable user ID, the name of the variable, and then the date type is 2. So it would assume that you have a ID of 2 on the users table, and maybe you would want a number 2 of user ID on the task, just to POC that there is a result. Now, this is again a comma, okay? So if everything works, you will see a printed task, a slice of task. All right. Mm, So now you can query, right? So you can manipulate data coming from the database. So the goal again is to actually export it to Excel. So let's try. Let's see how we will be able to do that. 7 change files and 67 additions. Hmm. All right. Now we have this export package, the export folder, and then the export.go. Let's just try to traverse everything for now. So you have the row names already, like the headers. Now we will be needing to have a dependency or the library called Excelize, version 1.4.1. So I think this go.sum is really automatic out of the box. And then on the main.go, the execution part, so it would have the export that build already. So let's go back to it later on. And then I made this as a collection now. And then I just remove this. All right. Okay. Now on the export.go, so again, it's on a separate folder. So we just have to reiterate that it would have a package export. And then our dependencies again is Excelize and then the task. So again, if you could remember, we have a struct of task. Now I passed here the task collection. So a while ago, I renamed it not anymore as a slice, but as a collection because I needed more flexibility. So I passed it as a parameter, and then now this function would build the Excel file. Now I needed to have the headers, so A1 to E1. So those are the columns and then the headers. So the first column would be the task ID, the title, is it completed, and then created at, updated at. Now the goal in mind is that okay, maybe I am a manager and then I would need what titles is completed or not. And then I would ask to mark the is completed to be a yes or a no versus like a one or zero, right? Because it's not humanly friendly or readable. Now, on executing this, we would need to create a new file and then for loop on the headers and then just put this headers. So I just POC'd like what does it look like, and then for loop on appending a row. Now I have here a function. So maybe let's go through that function. So it's a small letter because I believe it's going to be just used within this file for now. So append every row. We can add styles if needed because this is an Excel file, depending on the requirement of your boss or your stakeholders. And then we just pass in these arguments like a file, XLS file data type, and then the index because again remember that we have a for loop and a task collection. Maybe you'd like to access that. And then the output would be the file writer XLS file because essentially we would want to output it. So now we have this data manipulation. So I have here a +2 mainly because the headers is not counted. So I think I changed this to 1. But yeah. So the headers is like the 1 on the Excel file, not on arrays because on arrays it's like the 0, right? I think on the Excel file it's literally 1, so I had to add 2. I think it's really 1. Yeah. Now we just have to set the cell value from the sheet 1, and then I have here a sprintf, so like manipulation of the string. So on A1, like percent sign V or value. So again, this is an index. So um it would it would manipulate it to let's say A1 and then B1. And then you can see here that I could access easily the property. So I am accessing on the first column the ID, the title, and then here you would see I have a manipulation that if it's completed equal to true or equal to 1, I would yield or have it rendered as a yes rather than just a 1 or 0. So basically, this would append every time, append on the Excel file. And then finally, um, the file name is, maybe you could name it differently, but for now it's task.xlx, and then save it on on the temp folder as task.slx. If there's an error, it would throw it. Now, where is the execution part? So this is a global main function. So let's go back to main.go. Now we just have to call it from there. So export, so as expect that it is already there, and then dot build, that function we just created, and then pass in the task. Okay, we are so near. I think we are done, because essentially that's the final part, and I just updated the readme. But let's see the final file of main.go. So essentially, this is our final main.go, wherein you have to set up your global environment keys coming from your .env, and then find a way to have a connection from your database, and then um, query some data, let's say from your to-do app, the task table, and then maybe filter it by user ID, and then build the export file. Oh, there's the IntelliSense. Now, this build function file does the manipulation, the data manipulation, the formatting, and it does the saving of the export file. So let's see if how does that look. Hold on for a bit. So now it would look like this. So let's say it is already completed, it's a yes, and then our database has some titles in it. So now I hope you learned something from generating reports. And as I will go back now on my presentation, and yes, I'd like to thank Google Developer Space, Women in Tech, Jenny Stan, Lim GSC, and GoSG Tech Tune. And you can actually access this presentation here on this bit.ly link. And do we have any questions? Thank you.